Hello, everybody. Welcome to Arxan's webinar, Protect.NET Code, the Unmet Challenge. I'd like to thank you for taking some time out of your day to attend this webinar. So we're going to be primarily focused today on the .NET side of the house in regards to concerns about .NET code, tampering associated to that. And we're going to cover a variety of topics. We're going to cover security market drivers, what's really driving the need from a market perspective for some of the solutions that we offer. What are the threats that are out there in regards to managed code specifically? What are some of the transformations or mitigation actions you as an enterprise can take against those threats? The Arxan solution, guarded for .NET, and how it allows for you to meet the challenge, and basically a summary towards the end. So it's important to understand the reason that you should be thinking about security and what's happening in the market. So clearly, data that we're reading every day points to the threat that's occurring in emerging markets, increased risk over there, the fact that intermediate languages or managed code is really prevalent into the application development mind frame, and a lot of applications that are being written in intermediate code. Thus, that code, as you'll see throughout this presentation, is very susceptible to attacks. Specific threats that we'll outline will help you guys understand that a little more. Obviously, with the Web 2.0 evolution that's occurred, there's a variety of rich Internet applications that are being deployed to make the experience on the client side richer, and Silverlight being the .NET example, but others as well are highlighted, and those are primarily what's driving a lot of the adoption. So clearly, from a software IP perspective, a lot of the assets that we're building and writing every day have moved to the intangible side of the house. They're not physical, they're more conceptual at this particular point. So really it's about protecting your investments for the IP that you're writing, and different measures that you're taking from a licensing perspective that allow you to need to take action. So I think it's also becoming evident, based upon a lot of what's happening in the news and in our own experience, that the application is really the new perimeter. There's tons of solutions out there for network security, for endpoint protection, things of that nature. But really, a lot of the data that we're seeing from Gartner and from McAfee and other institutions, think tanks, those type of things, are really pointing to staggering amount of dollars being associated to loss of intellectual property tied to the application. And the concept of application security solutions has become more and more prevalent. Budget are being put aside for application security. So the overall security posture of an enterprise needs to encompass application security, just like it has and continues to do for network security and endpoint security as well. So enterprises are at risk because the amount of malware that's existent in today's world is staggering. The amount of unique malware exploits that have been tracked and are out there is in the hundreds of thousands, and the numbers are obviously just rising based upon the data that's being put out by the endpoint protection companies, McAfee, Symantec, those type of players. And there's really, the exploits are getting more and more complicated. The exploits are being obfuscated, and that's obviously leading to existing technologies that are there to detect. Those technologies are really ineffective against some of these specific types of exploits. So the result of that is a huge concern in the market, and a huge concern about seeing what you can do in regards to the protection of your code. Majority of the hacking attacks that are occurring are from the inside. Really, the perimeter solution, the mindset of sticking an appliance on the edge of the network is really not enough anymore, and you need to start thinking about different layers, specifically the application layer. So what are the threats that are really prevalent today in the black hat world that we live in? And what is software tampering? So software tampering occurs in many forms. Software tampering can be something specific in regards to reverse engineering of your IP, your specific code, your routines, your functions of code that really contain your intellectual properties. So stealing those routines, being able to reverse engineer the application, stealing those routines, and thus gaining unauthorized access to be able to take control of the application, to be able to thus circumvent certain conditional logic, being able to then distribute illegal copies. There's a variety of things that are opened up from the hacker's perspective if and when they're able to reverse engineer the application. Clearly, violation of code integrity occurs as a result of that, and they're able to introduce malicious code, malware into the program, or look to enhance the program beyond its original feature functionality. These are just some of the attack vectors that are known and really what results into tampering of your software itself. Now, how does that sort of manifest itself to the different market segments? Clearly, for enterprise threats, reverse engineering, tampering, and the different compromises listed here are extremely prevalent. Obviously, as we go to a Web 2.0 rich internet application world, as we're slowly evolving to, the amount of threats increase, and they increase primarily because you've now got a client-side presence with your web application, which is really susceptible to similar attacks to what native code applications have been for years. So distributed applications that have had threats against those are now, the same threats are existent towards rich internet applications. And then obviously from a software vendor perspective, you've got software application threats that are all through reverse engineering, code lifting, tampering, and really, it's about protecting your IP, disallowing somebody from being able to steal it, thus come out with competitive products. A variety of those type of compromises is prevalent across different market segments. So why would you want to make the investment of protecting your managed code? Well, managed code is clearly the route that most people are taking for building their applications. A lot of that is based upon the ease of development associated to managed intermediate code. A lot of that's because of the junior developer that's able to seamlessly write some rich applications using managed code. So there's less complexity. And where there's less complexity, there's also less complexity on the hacker side of the house. They're able to, as easy as it is for you to write the application, it's also just as easy for them to reverse engineer your application. So here you can see an example of a decompilation event that's occurred with some sample code. You've got some code on the left where the original code exists, and then towards the right you can see that as the application was put through a decompiler, a tool like Reflector, the original source code is pretty much existent in its raw form. So the comments that are there are obviously removed, but in general, everything but the comments carry over in this sort of an easy approach. And this is as simple as literally dragging and dropping an application, a binary, into a tool like Reflector and being able to thus decompile it. The next step would be to actually modify the source code to what you'd like, and then obviously recompile it, and now it's got additional behavioral feature sets that have it more to what you need it to do, and thus you've now taken control of the application or come up with a copy or whatnot. So it's as easy as this process to execute, and literally license management is an important aspect because that's just as vulnerable. If you've enabled license management in your product and you've got entitlement established, you should think about license management hardening in this specific context. Part of the thinking, I think, from an enterprise's perspective needs to be around developing a threat model, the ability to identify potential threat categories, understand each of those categories and what they mean to you, your business, your application. So the unauthorized access, where an attacker is able to run the application, perform operations by literally, no-opping or removing access control routines that are in its path, is a huge concern. Violation of program integrity, where they're able to go in and insert malicious code, is a huge concern. Obviously, exploitation of the application, where certain algorithms and functions and or sensitive data is extracted. And then the ability to analyze the program really from a debugger perspective, single step the code, examine the code, is a huge threat because they're understanding your control flow logic and they're able to thus make some decisions and take advantage of certain vulnerabilities that are being identified. What are some of the common attack tools? So common attack tools range from debuggers to disassemblers, such as ILDASM and assemblers. Decompilers. Reflector is a very commonly used tool out in the hacker community. Hex editors are an easy way to make hexadecimal changes to your programs to, once again, alter behavior. PE editors, which is really, PE is a portable executable. It's the Windows file format, and that's another classification of tools that's used. So really, if you look at this entire set of tools that are available out there, the hacker has at his or her disposal a plethora of options to use depending on the nature of the attack that they want to execute. These tools really aid in the automation of the reverse engineering process. So what is that process? What is the hacking process? And really, it's at a high level. It can be specified in 4 steps. They're able to go in and gather information around the program by using some of the tools and processes that I mentioned earlier. Once they're able to do that, they're able to locate and analyze the vulnerabilities, which is really where the work starts. At that point, they're able to then formulate how they want to do the attack. Now that they understand the logic, they're able to figure out how they can exploit the vulnerabilities, try a scenario, and obviously with the reverse engineering that's already taken place, they can try multiple scenarios, and eventually one will lead to the exact result that they're looking for. So as an enterprise, what can you do about that? From a white hat response perspective, how can you help meet that challenge? So there's a lot of things you can do in regards to understanding the attacks. Education is a huge way to come up to speed with how susceptible your code is, what you should be doing proactively. Understanding and attending webinars like this or doing some reading is a huge way to understand what you can do for current releases, future releases. Developing ways to defend against these attacks once you've understood the attacks is important because now you're starting to think about mitigation schemes. Wherever you can eliminate vulnerabilities based upon the known attacks from a source code perspective is obviously a good approach. But then there's other protection techniques and mechanisms that can be put into place that are really non-invasive and come into play at the end of your software development lifecycle, really without impacting your developer, and that's part of what we're going to talk about later with Guarded for .NET. And then obviously you want to continue that process because security is an iterative process, and you never are done with one release or one specific implementation. You have to repeat, you have to enhance, and continue to understand future limitations. So here you've got the obfuscation capabilities. So a lot of tools that are out there for .NET are focused on obfuscation. And obfuscation primarily is a technique that's been around for years on out. It's been used by a lot of in-house developers, various forms of obfuscation, and there's various books, articles to read about obfuscation. Here's an example of a couple of books that we'd recommend for you guys to understand better how to protect your code, how to leverage various obfuscation transforms. And there's a lot more, but this is a good example of how to get educated. But obfuscation, I think to keep in mind, obfuscation is not enough by itself. Encryption wrapping type of technologies are not enough by themselves. Technologies that sort of leverage a parallel process or a thread, processes that set up a secure execution monitor alongside your application. Those type of techniques are really easy to compromise. And the thing to be concerned about obfuscation is, yes, it will frustrate hackers, especially the hackers that are not as sophisticated in regards to their capabilities. But is it enough? What is the overhead associated to it? Having that flexibility to where you can control the type of obfuscation that you introduce is extremely important, because just going through a COTS product or some sort of a blanket protection, you will find out is less than adequate for today's sophisticated world. So here's an example of .NET code that's been obfuscated. And on the top, you've got the original program. So this is a decompilation of the original program, as you saw earlier. Very easy to do using a tool like Reflector. And then towards the bottom, you've got a low resiliency type of solution from an obfuscation perspective, where some of the code has, basically is still evident, and you can basically see that although the code has changed somewhat, the code and the logic is really clearly discernible. And that's really the important point for a hacker, is they're able to easily discern the logic behind your code, even though you think you've taken some positive and proactive obfuscation steps. When you think about advanced obfuscation and various types of obfuscation transforms, that's one of the many capabilities that Guarded for .NET inherently offers. So here you've got an example of an Arxan Guarded for .NET protected application. And first thing you'll note that the decompilation wasn't really complete because of our capabilities to break some of these decompilers. So we actually have anti-decompilation technologies within Guarded for .NET. And secondly, you'll note that there's really no info about the actual logic in the disassembly, which is extremely important because the level of frustration for a hacker goes up exponentially when they're looking at decompiled code in this manner here. When it's really, you can see at the bottom, decompilation failed for this method. So you can see that there's multiple stages of obfuscation, different levels of sophistication, and Guarded for .NET offers a variety of techniques, obfuscation just being one of them. So let's talk a little bit about Guarded for .NET, Microsoft .NET Framework. Guarded for Microsoft .NET Framework is really a solution that operates at the binary level. And what we mean by that is it comes into play post your build process. Really, it's a technology that's driven through a GUI. It allows for you to seamlessly consider protection using a variety of techniques as you would consider developing using Visual Studio. It's that type of an interface. There's that type of flexibility. And it includes an extensive guard library, which allows you to pick and choose the type of transforms, the type of guard types that you would want to use. Now, in addition to protecting your application, some customers of ours have wanted to leverage a business intelligence capability that would be baked into their application. Instead of protecting only, maybe they're looking to gather information. From our perspective, that's just one of the many features that we offer. And then the other point to highlight here is the mixed mode aspect. Clearly, in today's world, with the variety of technologies that are being used, you've got the ability to have code that is both native and managed. And Guarded for .NET, in conjunction with Guarded for Windows, allows for you to seamlessly protect your mixed mode assemblies. So you can have an example of application logic that is in C#. You could have licensing layer and abstraction layer that is in C++ native, and then you can have the licensing library. Now that all has to work together, and clearly you want to protect those different layers, and with the technology that covers mixed mode assemblies, you're able to basically do that. So what is the guard behavior? Guards are basically small components, small object code modules that are inserted into your application surgically, depending on where you'd like the insertion to take place. And they basically transform code at protection time. They also execute at runtime, and that's really the power of the solution here, is that you've got the ability to provide guards that are not only protecting code, but you've got the ability to use guards that are protecting themselves. A lot of ability within the solution to allow creation of multiple instances, variety of diversification options, a lot of techniques that are basically within your control. Now, the overall solution is a very low impact, and the reason for that is it's low impact from a development perspective because there's a GUI that allows you to seamlessly build a protection in a relatively automated fashion. You've got the ability for tunability because clearly, everybody has a different application for different business reasons with different various components, and you want to be able to tune that protection technique to exactly what fits you, and this type of a solution allows you to do that. Now, performance is another component that's important for customers depending on their business needs, and that's also extremely tunable because you're able to dictate the number of guards, the type of guards that you would instrument onto your application, thus keeping within the boundaries that you've established, both for performance and or any other capabilities that you would like to adhere to for your application. Guard scripts are really the blueprint of the protection. A guard script is really what you define as to how you want to protect your application, and they're very easy to reuse across multiple builds, multiple releases. There's various ways, as I mentioned earlier, to execute upon diversification, where you can change seed values and various randomization characteristics of your protection, the same protection, and it would thus produce a different end application. So Guard Network, I touched upon this a few minutes ago, but Guard Network is one of the key differentiators of an Arxan type of technology because it allows for a high degree of protection by eliminating a single point of failure. So typically you have certain protection techniques that are set aside to protect specific functions or ranges of code. And in this case, you've got a password check routine that has a checksum capability put upon it. But really the guard network comes into play when you introduce layers of guards. So you've got guards protecting guards. In this particular case, you can see that the checksum guards are specified. They're protecting one another. You've got obfuscation included. So basically what you're establishing here is a firewall type of an approach, but within your application, where you've got multiple layers of defense or multiple layers of a firewall established within your application. And a lot of our customers think about this in the context of a software embedded firewall. You're embedding guards, which are acting as a firewall, and then you're able to establish multiple layers of these guards and thus increase the level of protection you're getting to a point where you're feeling like the application is more secure than it would be with other solutions that are really isolated down to a single point of failure. So some specific transformations that we offer from an obfuscation perspective out of the box are focused around data, control flow obfuscations, layout obfuscations. All of these techniques are available in the product and available out of the box for use within the interface. In addition to that, we've got the ability to use different types of guards. So you heard me mention obfuscation. You heard me mention the renaming capability, encrypting strings. The checksum ability is one where a checksum guard is actually injected into your application. So this is just an example of the different techniques that are available for the Guarded for .NET product. And the ability to leverage one or all of these is really left upon you as the enterprise to decide how you want to control the protection, how you'd like to expand the protection over time. A lot of our customers deploy a simplistic protection maybe the first time around, and then they increase their protection as the releases mature from a product lifecycle perspective. So in summary, attackers are really looking at your applications in 3 steps, and Arxan has the ability to block all of them. Number one, they're working to disassemble your application. As we've shown through a couple of screenshots here, it's very easy to convert everyday.NET and Java, for that matter, back to full source. It's literally a drag and drop type of mechanism that allows for that to occur. And having a strong protection technique, having various layers of defense are important. And Guarded for .NET, because of various obfuscation strategies and other guards, allows for you to do that. Number 2, manually comprehend the obtained source. So searching for certain patterns and semantics to find vulnerabilities is a very common approach from an attacker's perspective. And using Guarded allows for you to disallow for that as well, because of, once again, the same techniques that we offer, which disallow for the disassembly and obviously for the ability to be able to understand the source code. Number 3, and really the most fearful for enterprises out there, is that not only is the hacker able to disassemble and understand the source code, but they're able to create a BOR exploit, which is really a break once, run everywhere exploit. And what that means for you is that they're able to not only reverse engineer and take advantage of your existing application, but all future applications as well, because they've figured out what to look for, how to have it be repeated, and it becomes an automated process for them for every release that you put out. And obviously with the various diversification mechanisms that we have within the product, Guarded for .NET allows for you to not be concerned about that in regards to that being a potential problem. Now, mixed mode capabilities is a huge differentiator for Guarded for .NET, and clearly that spans both native and .NET portions of your application. So the net result here, and that's important to walk away with, is you're getting a durable, easy, and effective protection for .NET, which in today's world, with the prevalence of .NET and also with the hacking abilities that are out there, in addition to the tools that are readily available, it's a must-have. You have to have some form of protection or preventative action in place, and Guarded for .NET is the solution to allow for a strong protection and for you to feel confident that your applications are in fact tamper-proof. So with that, I would like to thank you for your time today, and if you'd like to download our white paper, you can go to www.arxan.com and search for security white papers. You'll see some white papers for .NET, for native. We have a variety of solutions in addition to the .NET product, and we also have demos that are available through the website. And, of course, if you'd like to further discuss things, we can do an eval and a variety of things there. So once again, thank you for your time, and I look forward to talking to everybody the next time.